This video is for just a kind of overall general review of this chapter of what it means to write equivalent expressions. So I think I've used this phrase a few times. I've asked you to write equivalent expressions. I want to make sure we are all understanding what I mean by an equivalent expression. So in order to write equivalent expressions, there are several different ways we can do this. There's no one right way to do it unless it says to put it in simplest form. That's different than asking for an equivalent expression. So equivalent expressions, you could use the distributive property. You could use the combining like terms strategy. You could factor. Or you could do something else, which basically you could use a factor other than the greatest common factor. You could expand it. You could do a whole lot of different things. So I will show you an example of how to do something like number 4 where it says other. So let's take a look at an example. So if I gave you this expression, 3 times the quantity 2x plus 8 minus 2x, if the directions say to simplify, then there is one clear correct answer. If the directions just say to write an equivalent expression, there are actually an infinite number of possible correct answers. So one thing you could do is you could just distribute the 3 to the 2x and the 8, and you could write 6x plus 24 minus 2x and be done. So this would be one equivalent expression to the original expression. That's if you use the distributive property. You could take it a step farther and actually combine the 6x and the minus 2x and make it 4x plus 24. This is actually in simplest form. That would be an acceptable answer. And then another option is to factor it. Remember, factoring means that you're going to pull the greatest common factor out, which would be 4. So that would be x plus 6 inside. That is a third option for your answer. And then for 4, you could literally do anything for this. So one option is to factor something other than 4, like 2. So you could do 2 times 2x plus 12. That's the only other common factor that 4 and 24 have in common, so that's the only option for that. But you could also rewrite your answer basically in any way. So for example, we know that the final answer is 4x plus 24. You can basically break that up or expand it however you want. So you could take the original problem and you could rewrite everything the exact same way as it was written. But where it says minus 2x, you could write that as minus x minus x. That's equivalent. So minus 1 makes a minus 2. You could write it like that. You could take the 4x plus 24 and you could write it as x plus x plus x plus x plus 12 plus 12. There's infinite amount of options here. You just want to be careful that whatever you write is actually equal to the original expression. So just be careful. Sometimes people try to get creative, which is great, but just make sure your final answer actually equals what we started with. So question says we have 3 different options, and the question says determine whether each expression is equivalent to 2 times the quantity 2x plus 1. So number 1 is 4x plus 2. And that is, yes, that does equal 2 times the quantity 2x plus 1. If you distribute the 2 through, you would get 4x plus 1. The second example says 2 times 2x plus 1. And that does not equal because we only multiplied 2 times the 2x, but not the 1, which is not the same. And then for question 3, 2x plus 1 plus 2x plus 1. Yes, that is equal because another way of multiplying by 2 is that you can just add the quantity 2x plus 1 to itself. Okay, so for a final example, I want you to write any equivalent expression to 9h plus 15 minus 3h. Your choice of how you want to do it. You can be as creative or as simple as possible. Just make sure it's different from what you see on the screen, but also equal. One final question, which expression is equivalent to 2r minus 2 times the quantity r minus 3 plus 3 times 2r? And the answer here is D. 2 times r is 2r, minus 2 times 3 is 6, plus 6r, 2r, and 6r is 8r.